Okay, I'll wait for your go ahead in that case.
Yeah, I think, I can go ahead. Okay, welcome back, everyone. So our next talk is actually going to be a nice technical talk, and we're going to shift from, the application of AI from large language models, but now we're going to move on how AI and machine learning can actually be applied in other sectors. And we are actually privileged to have Dr. Robert Ambuda, who is actually senior lecturer and transport specialist and a senior lecturer at the University of Namibia. And he will be talking about the application of artificial intelligence and machine learning paradigms in the Namibian transportation sector, the status quo and opportunities. Dr. Ambuda, please take it away.
All right, thank you very much for that kind introduction. And it's good to see, or at least know, that we've all managed to brace the winter this particular week. As introduced, my name is Robert Ambunda from the University of Namibia. And at the University of Namibia, I lead the Transport and Mobility Research Lab and also serve as a co-resource person for the Volvo Research and Educational Foundation's Mobility and Access Next Generation Research Program. Perhaps just an apology from my side. I'm currently at the location with low bandwidth, so I will share a picture of mine for those who would wish to see my face. Today, I'll be talking about the application of AI -ML paradigms in the Namibian transportation sector. And that will be focused around the status quo of the applications, as well as the opportunities that exist in that particular space. Firstly, I would like to just give out a structure of the presentation. I'll go on about artificial intelligence and machine learning, and then I would explain why AI in transportation system, followed by its application areas, and then specifically its application in transportation, and then its application in the Namibian space, and then the opportunities that exist as well on how we can apply and improve the technology within transportation in Namibia. So when we talk about artificial intelligence and machine learning, we specifically ask ourselves, what are we talking about? Perhaps in less technical terms, we can explain AI as a bigger concept to create intelligent machines that can stimulate or simulate human thinking capabilities and behaviors, whereas machine learning is an application or a subset of AI that allows machines to learn from the data that it has been fed without being programmed explicitly. So at the present time, AI methods can be divided into two broad categories, which are symbolic AI, which focuses mainly on the development of knowledge-based systems, and computational intelligence, which includes such methods as neural networks, fuzzy systems, and in many cases, evolutionary computing as well. So why are these paradigms ideal for solving transportation dilemmas? Transportation in itself and the problems that exist within that space exhibits a number of characteristics that make them amenable to solutions, especially using AI techniques. Firstly, transportation challenges often involve both quantitative as well as qualitative data. And the fact that we often have to deal with qualitative data in transportation makes the use of experts in fuzzy systems an obvious choice to apply within that space. Secondly, within transportation, we often deal with systems whose behavior is very hard to model with traditional approaches, either because the interaction among the different system components are not fully understood, or because one is dealing with a lot of uncertainty stemming from the human component of the system. So for such complex systems, building empirical models based on observed data may be the only option remaining. So neural networks, given their universal function around approximation capabilities, are quite perfect tools for building such models. Another thing regarding transportation challenges often lead to challenges in optimization that are quite challenging to solve using traditional mathematical programming techniques. And this is either because the relationships are hard to specify analytically, or in some cases because of the size of the problem and its computational intractability. So for these particular problems, you find that genetic algorithms may provide an alternative solution approach to approaching some of these challenges. And then finally, the complex nature of transportation systems generally, and the fact that their behavior emerges as a result of an interaction among the system components, provides agent-based modeling techniques as one of the appropriate solutions for studying the behavior of such systems and addressing some of the challenges that emanate from those particular systems. So before we get into the specifics of how AI may be used in transportation, it's important to understand the notion of intelligence in transportation. You find that intelligence is required to guarantee that transportation services and goods are delivered mostly in an efficient as well as in an effective manner. So data collecting technologies can currently gather and handle enormous volumes of traffic data, but only if the result is meaningful and comprehensible to the user or the system controller in this case. So intelligence, which requires a clear grasp of the user's goals and the relevant information available, is more useful than information generally, which can only be useful if relevant to the user's particular situation. So AI application areas are quite diverse, especially within transportation. And here I've just given some of those application areas to which AI methods have been applied over the years and explain how this may be relevant to transportation applications, not only within our particular case, but generally within the transportation space globally. So among the most important AI application areas, we have system identification and function approximation, which is mostly concerned with building empirical dynamic models of systems from measured data or mapping system inputs to outputs. So as previously mentioned, in transportation systems, many of the interrelationships between the variables or components of a transportation system are not fully understood. So given this, empirical models are quite common within the space. And then nonlinear prediction, which focuses on the prediction of the behavior of a system, where the relationship between the input and the output is not linear. So this is often the case with transportation challenges and problems, including predicting traffic demand or predicting the deterioration of transportation infrastructure, that being a function of the traffic using that particular infrastructure, its construction, as well as a myriad of other environmental factors that play a role in the damage as well as deterioration of transportation infrastructure over a period of time. And then control, which focuses on controlling a system so as to achieve a desired output. And you find that control applications are bound in transportation. Examples would include now signal control of traffic at road intersections. So I'm sure we've observed quite a number of those within the urban vintage setting. Ramp metering on freeways, dynamic route guidance, positive train control on railroads, as well as air traffic control. So it does have a space to play within the transportation systems. And then you have pattern recognition or classification, which describes a broad range of problems where the goal is to classify an object or put it in its right class or category. So pattern recognition is often associated with image processing, although many prediction problems can also be regarded as a pattern classification problem. So examples of pattern recognition or classification challenges in transportation include automatic incident detection, for example, classifying the traffic state as incident or incident-free, image processing for traffic data collection, and for, in some cases, identifying cracks in pavements or bridge structures. So another example can also be involves equipment diagnosis, especially at way bridges and other similar systems within the transportation system. Clustering, which refers to the problem of grouping cases with similar characteristics together, and then identifying the number of groups or classes. So within that, for transportation, clustering could be used to identify specific classes of drivers based on driver behavior, for example. Planning, which refers to the act of formulating a program for a definite course of action intended to achieve a desired goal. If I can relate that to transportation, the goal of transportation planning process is to identify the transportation needs of a community and to recommend the best course of action required to meet those particular demands, while at the same time taking into account the economic, the social, as well as the environmental impacts of a transportation system that's going to be planned as well as implemented. So AI-based decision support systems for transportation planning could be quite useful, especially when accurate analytical models are lacking and when problems involving multiple stakeholders with often conflicting objectives exist. When it comes to the design aspect, which is a key activity of the transportation engineering profession, including geometric design of highways, interchange design, structural design of pavements and bridges, culvert designs, retaining walls, guardrails, just to list a few. So AI methods within that space could add to the value and capabilities of computer-aided design, which is now commonly used for engineering design applications by providing additional decision support capabilities. And then the concept of decision making, which refers to the cognitive process of selecting a course of action from among multiple alternatives. So you find that transportation officials are continuously faced with challenging situations where they have to make decisions in very demanding situations. So examples of these situations include deciding whether to, let's say, build a new road, how much money should be allocated to the maintenance of that particular road, rehabilitation activities, and even cases where you have to decide which road segments or bridges needs to be maintained as a priority, and whether to divert traffic to an alternative route in a case of an accident or a situation similar to that. And then the optimization, which refers to the study of problems in which one seeks to minimize or, in some instances, maximize a function by choosing values for a set of decision variables, while also satisfying a set of constraints. So optimization problems in transportation are quite a lot. Examples would include designing an optimal transit network for a given community. So developing an optimal shipping policy for a company within maritime space, or developing an optimal work plan for maintaining and rehabilitating pavements in that particular case. So at the end of the day, the overall goal of intelligent transport systems is to help controllers and other users of the network make better decisions. And this is often in real time. So you find that this improves the overall efficiency of the transportation system. So ITS tactics may be improved by obtaining more precise and more complete data to improve the connected system, which then reduces the need to make assumptions about the characteristics of traffic within the transportation system. So you also find that faster, more efficient, more affordable, and cleaner transportation can be summarized by the role that AI plays within that space, and essentially big data as well. So intelligent solutions and technologies help to transform the way we transport our goods and the way we transport our passengers. No matter where you look, whether it's in aviation, whether cargo transportation, public transport, intelligent technologies help to make the space particularly more efficient and overall better performing. So we'll look at these three spaces on its application in Namibia through research and other practical applications in Namibia. So at the Transport Mobility Research Lab at the University of Namibia, we've undertaken a number of projects within the space, and I'm just going to share three of those that we've been busy with at the moment. And the first project being that we developed intelligent smart traffic lights where infrared sensors were used to reduce congestion at intersections in Ongwediva. The time allocation in this case works on real-time data. And these traffic lights are intended on having an additional feature of implementing a sleep mode if the lane entering, for example, let's say a mall, has been inactive for an hour to save on energy. So in this particular case, we used or utilized a software called PTV Vism and Proteus software to simulate and to develop the prototypes, which is the one on the top left corner in this case. Another project that we have worked on was the design and development of a solar-powered Internet of Things device to visually detect and count vehicles, as well as to exchange data with other devices and systems over the internet. Because the system is trained to detect and count vehicles while differentiating other objects, it can easily surpass human capabilities. And we find that the proposed system effectively detects and counts vehicles, especially in the region in which it was trained, in this case being Ongwediva. The third project, which I'm always very excited about, is entirely being developed using Moodle, where we've investigated the capacity of the road network to handle the current traffic going through the main road. In that particular project, we applied various intersection control techniques from more traditional means, such as stop signs, roundabouts, and so on, to more technically advanced, such as intelligent traffic control systems, in this case, intelligent traffic signals. So this project is still running and is funded within the TMR, and we'll be excited to share the results as they come along. Yeah. So within the shared mobility or the sharing economy and mobility, particularly driven by AI, this has proved popular in congested metropolitan regions, especially in dense urban areas. And this is due to its ability to remove single or fewer occupant personal auto vehicles off the road. So you find that this is a win-win strategy since it provides immediate economic and environmental benefits, while also allowing for long-term sustainable solutions to be adapted. So I've also found that there's a number of mobility as a service systems being offered in Windhoek, which in this case are Lefa, InDrive, and Yango. I'm yet to use some of these systems, but it's quite exciting to know that we have some of these systems that are already operating within the mobility space or the shared mobility space in Windhoek. So Also, due to the importance of bus journeys and destinations in public transportation, you find quite a lot of research that has been conducted to enhance the safety and dependability of public transportation systems. You find that the bus timetables that are used are regulated by an algorithm known as the ant colony hybrid, which is mostly used from BRT systems, so bus rapid transportation systems, and to even more conventional public bus operations. So when it comes to maximizing the scheduling of bus drivers and user timetables, you find that both can be made reliable and successful using intelligent transport systems. Bus riders may save time by using artificial neural networks to anticipate when the next bus will arrive. In that particular case, at bus stops where you have these calendars that are automated. So in addition to automobiles and automated buses, this is just another application of this particular technology. So when it comes to opportunities, we want to find where do we have the space to improve the technology and even operate as researchers, as consumers, or as business people within the particular space. So improved decision-making based on real-time data and improved network utilizations are the future ambitions for intelligent urban transportation. The construction of a transportation system that is more dependable, a system that is efficient, a system that is environmentally friendly, all while retaining a high degree of connectivity is very important to make sure that you provide a system that benefits both the users and is quite user-friendly as well to the operators. Talking about connectivity, we've known for some time that autonomous vehicles were on their way, but it seems like, they are finally here. So developing AI software for connected self-driving cars relies on the usage of deep learning algorithms. So with this method, you can teach the automobile how to drive while still maintaining safe headways, ensuring that there's lane discipline for that particular vehicle, and overall just control of the vehicle. So foreseeing how AVs could impact travel patterns and the safety and congestion of roads throughout the region and the globe, it has taken into account a variety of considerations. These self-driving cars will change people's travel patterns, perhaps resulting in, who knows, new social structures or even new urban forms. For example, they will help to create a new business model for cars and ride-sharing services, like I mentioned, the leffers and the in-drives and so on. This will then help to overcome some of the present restrictions, such as a lack of accessibility and reliability. So you find that some of these local services, such as leffer and so on, will have to adapt to the new social and technical disruptions that come with these autonomous vehicles. One other space of ITS that has picked up and continues to be a golden area for research and even for practitioners to explore is driver behavior monitoring systems. So this can be used to reduce traffic accident risks, mostly. And you find that most previous methods for monitoring driver behavior mostly rely on computer vision techniques. The time when I did my PhD, which was around road safety, I briefly touched on driver behavior monitoring systems as one of the key systems that in the future can help to address road safety issues, especially from a behavioral point of view. So we can see that the range of applications within the transportation space is vast. And, it's expected to increase as our cities and as our transportation systems become more instrumented, providing much needed data for AI application development. Application areas which are expected to have more influence in future cities will include the development and fine-tuning of the space of autonomous vehicles, the space of public transport, disruptive urban mobility planning, automated incident detection, future traffic status prediction, which is quite crucial for transportation planners when designing their systems for traffic that is expected within any particular residential area that is being developed. Traffic management and control, and a ton of other spaces in which the paradigm can quite assist a lot. So it shows that AI can be used to solve the challenges of increasing demand, CO2 emissions, climate change, safety concerns, and in many cases, wasted fuels, which ties in with environmental friendliness of the system. So at the TMR, we always say that we intend on creating value and sustainable solutions for our stakeholders and partners within the space of transportation and mobility. So we are looking to collaborate with anyone who's within that space in order to improve the systems and to make sure that we provide better value for road users in Namibia. So you are more than welcome to contact me for any further information, and I'd be happy to take some questions. Thank you.
Thank you very much, Dr. Ambuda, for that enlightening talk. And we'll definitely see how we can collaborate. We are technical specialists, and you have the domain expertise, and you are also an engineer working on sensors, so we can see how we can actually collaborate on some of those projects. But however, due to time, we will not have any opportunity to take any questions at this stage. But the delegates have actually taken a screenshot of your contact, so they will be able to contact you. I, for one, will definitely contact you. Thank you very much.
Thank you very much, and looking forward to hearing from you. Thank you.
Okay, great. Okay, yes. So our next talk, we are going to have another technical talk before we move into the panel, which was supposed to happen yesterday by Mr. Venik Mashuna, who is a senior data scientist and robotics process automation developer at the Bank of Namibia. So Mashuna, the floor is yours. Everyone.
Thanks very much for this great opportunity to join the IndabaX program. So, as well introduced by Dr. Lamek, my name is Philip Mashuna. I'm the senior data scientist and RPA developer at Namibia. So, just a bit of background about myself. I recently joined Bank of Namibia a few months ago. Prior to that, I worked with Bank Namibia, where I was also a data analytics and fresh RPA developer. So I've quite worked on a few AI-related projects as well as RPA projects. Okay, and today, ladies and gentlemen, I will just give a brief introduction on artificial intelligence and machine learning. And please do accept my apologies for showing up this. But we have this presentation done yesterday, but for some unforeseen circumstances, I will not be able to apologize. Okay, so these are the content. So we're gonna go through exactly what AI is, AI versus machine learning versus deep learning, since these words are kindly mostly used interchangeably. Then we're gonna deep dive into what exactly is machine learning, deep learning. Then we're gonna touch on application domain on AI and ML. Then we're gonna focus more on the AI and machine learning methodology, which is the most important topic for the day. Okay. So, what is exactly AI? Maybe I can ask the audience, what comes into your mind when you first heard about AI and machine learning? Or is it the first time hearing about artificial intelligence and machine learning? Okay. First of all, back in the days, when I first heard about machine learning, what came into my mind was a physical robot, or the one from the movie Terminator. So that's what came into my mind when I first heard about the word machine learning. So I was thinking of an actual machine that is doing something. But in actual fact, AI and machine learning is simply just a field of science of creating this solution that simulate human intelligence, or creating algorithms that learn from past experience, which is actual facts, data set. Okay. So let's talk about the distinct difference between AI, machine learning, and deep learning. So in actual fact, artificial intelligence is the umbrella, is the parent of all the rest. So under artificial intelligence, we have machine learning, which enables machines to learn from past experience, which is of course the data set. And we have the deep learning. So the deep learning simulate how the human brain operates. So just the clarity on deep learning. So deep learning is not a replica of the brain, but it tries to mimic how the human brain works. Because I heard some people say that we have deep learning, so it means that it works the same way as the human brain does. Okay. On just to dive deep more into artificial intelligence. So in artificial intelligence, in the world of digital and increasingly in the world of increasing technology. So we first of all need to evaluate the journey towards artificial intelligence. And we have, based on the AI capability, they are mostly classified under 3 types, which is now the weak AI, general AI, and strong AI. So under weak AI, where the journey towards artificial intelligence is mostly weak AI and a bit of general AI. So under weak AI, we have the rule-based system. This one represents the early stages of artificial intelligence, where these intelligence systems that have been created follow a certain predefined set of rules. but then it doesn't go as far as adapting or learning to new context. So such an example of that is like playing a game of chess with a computer. So the computer knows exactly what the types of ways to play chess, but then it doesn't go as far as going with thinking contextually or going beyond the predefined set of rules that it has been programmed to follow. And secondly, we have context-oriented AI machine type of machine, which represent now the evolution of artificial intelligence. Now, this is where we make use of machine learning and AI techniques such as neural networks and other type of machine learning techniques. So with machine learning is mainly classified under three types, which is supervised learning, unsupervised learning, and reinforced learning. Supervised learning basically works on labeled data. So we know exactly the outcome of the historical data. And then we teach now the machine how to contextualize what has happened and make future informed decision based on what has been happening. And we also have unsupervised learning, which is not which does not really work on labeled data, rather than it's up to the system to decide based on the relationship and data points between them to classify this type of data into categories. And of course, we have reinforcement learning. So reinforcement learning is more on the way we as human learn. We learn from experiencing or experimental, doing something over and over, trying it out, failing, then trying again for the second time out till we get it right. So that's exactly what reinforcement learning is all about. And of course, deep learning, I've touched base on that, which mimics how the human brain works. Okay. So moving on, let's just dive into machine learning a bit. So under machine learning, we have supervised learning algorithms. So this algorithm can also be classified into two types, which is regression and classification. So with regression is more on whereby the targeted outcome is more on which is the empirical value. While classification is more qualitative outcome. So I'm not going to dive deep into this because no one has enough time, but then I can just run through them. We have the first one, which is the naive base, basically based on Asian statistic and probability. We have the K-nearest neighbor, which works on Euclidean distance. Okay, then we also have the decision tree, which is a hierarchy. It classifies objects in different hierarchies. So, like for decision tree, can also be used for both regression and also classification as well. Then we have now regression models. So, what are regression models? We have linear regression, which most of us are familiar with. We have multiple regression, logistic regression, which is one of the only classification algorithms that we have. Then we also have neural network, support vector machine, and this is just a few, to name a few. But then since now the technology has been increasing on a daily basis, we have other algorithms that we're not even aware of. Okay, and under unsupervised learning, we have cluster techniques. Under cluster techniques, we have hierarchical. K means clustering, and also K-modes. Further, we have principal component analysis and association rules. So association rules is mainly to classify those elements that we have some sort of association in them. Moving on to, sorry for that. Moving on to deep learning. So within deep learning space, we have a few models, one of them being the artificial neural network, which is the fundamental building blocks of deep learning. It's the early stage of deep learning. Then we have convolutional neural network, or CNN. This one is widely used in image and video processing. Then you also have recurrent neural networks, which is mostly used in natural language processing, such as an example, like ChatGPT, which you make use of GPT technology. Okay, we also have generative networks, or GAN, which consists of two neural networks. Sorry. Okay. In terms of AI and machine learning application domains, so AI is widely used in all aspects of all business area, ranging from healthcare, transportation, as alluded by Dr. Robert, manufacturing, custom services that make use of chatbots. Also have natural language processing, retail, cybersecurity to identify those threats, and of course, agriculture. Okay. Before I touch base on the artificial intelligence machine learning methodology, maybe I would like to hear from the crowd. Is there any question?
I didn't see like the financial sector, so can it be applied?
Yes, of course. These are just few application domain, but as I said, it can be applied in all business areas, ranging from all of them. So these are just a few, to just mention a few of them, but then can be applied. Since I'm from financial, that's why if you can mention this. Yeah. Okay. Okay. Study has shown that over 80% of AI ML projects fail. And yeah, that was the study done a few years ago. And but I do agree, because I'm speaking from experience. I also experienced this type of failure. Create models, but then they are just left without being deployed to production. So, but this reason mainly comes from the methodology. Without following proper method to execute this type of algorithms. So we don't just create a model for fun, we create an AI ML model to solve a particular issue. Business issue, since I'm from the so business issue. So and the widely used methodology method is what we refer to as CRISP-DM, which stands for cross-industry standard process for data mining. Not only data mining, but then we also expand this to AI, ML, and all of it. So when it comes to this methodology, it mostly have 6 steps, sometimes also 7, depending on the complexity of the problem. It's business understanding. And with business understanding comes with the overall business strategy. So when we have your business strategy in place, that's now when we come up and also try to design a data strategy which speaks now the overall business strategy. Because when you build this artificial system, it's for them to actually solve a problem. And when it comes to solving a problem comes in mainly in 3 ways, three types. It's either an issue. It's an issue. Let's say in the banking industry, people are needing the services. So that's an issue. Or it could be a threat. Or it would be a competition. Now, FNB introduced a new technology that does ABC, and now network feels threatened because more people are now moving away from it. So there are mainly 3 business problem types. So when it comes to the whole project life cycle, it starts with business, sitting with business to gather all the requirements. So you assess the current as is business process, and then assess now the desired outcome. Then we can see how artificial intelligence machine learning algorithm will bridge the gap between the current business as is process and the desired. So moving on, the second one is the data understanding. One, we have a clear understanding of the problem specified by business. Then we move on to the second stage, which is now the data understanding. We have adequate data to solve this particular problem. That's the first question that we ask. And if we do have the data, where is the data currently sitting? Is it something that is accessible to us? First of all. And is the data, what type of data do we have? Is it structured? And most of the industry data we are working, it's very noisy. So it's very noisy, meaning that it's a lot of information, and it's difficult for you to clearly understand the type of data to use. And the third one, which is now the data preparation. Let's moving on, progressing. Once we have a clear understanding of the type of data that we're using for our model, then we need now to prepare the data, because the data is in different format, sitting in different sources and all that. So we need to bring them together and prepare it for the model. So in actual fact, the first 3 stages of the methodology takes up about 80% of the entire project life cycle. So that's where the massive amount of work is dedicated to. And it's iterative. So the methodology is not a clear, progressive, linear progressing life cycle. It's an iterative. So it could be that you get the data, but then you still have to go back to the business and gather more requirements for business. Then that brings us now to the fourth stage, which is now the modeling. Selecting the right model for the problem. Right. Okay. As I said before, for the first stage is where we select the best model for the problem based on the complexity of the problem and each of the problem. Whether it's a supervised learning type of problem or unsupervised or reinforced. So once we build this model based on the prepared data set, then we evaluate. That brings us to the fifth step, which is now the model evaluation based on the data provided. So we evaluate the model. So mainly when it comes to data set is mostly split into two things: the test set and the training set. So the training set will never be part of the test set will never be part of the training set, because the test set is part of give the model 100% accuracy. So we test the model using the training data set, and then once we are happy with the result and the accuracy of the model, that's when we apply now the model onto our testing data set. And of course, if we are happy with the accuracy and the outcome of the model, that's when we go forward and deploy the model. And I would like to ask colleague, have any of us built an AI model that was deployed to production? Even not to production, but a model that can be used in something.
Joseph.
Okay, Joseph.
I did data translation for so it's on. It's not. So we started because of inference. Also compute research. It went on for 1 month.
Yeah, I do agree. This kind of AI ML is not something that you can do overnight. It takes a bit of time, it takes months, especially if you are given a complex problem. So it takes time. But in terms of deployment, so the deployment depends on the type of model that you have built and the audience that will be making use of for AI solution. So if it's if it's a model that's open to the public, so we go for web deployment, web service deployment, or creating REST API for the model. But for some minor model, that's something that you can mainly deploy on your on-premise servers and so forth. But now, as we are living in the world of big data, I prefer people to make use of cloud-based deployment, such as Google Cloud, Azure, Microsoft Azure, and AWS, and so on. Right. Sure, I covered everything in artificial intelligence and machine learning methodology. Okay, for the conclusion, remember how internet and electricity changed the way that's exactly the same way AI and machine learning will change the way we live. And I guess you will be one of the leaders to do that.
Thank you so much. Do you have any questions? I see from the back there. Can we have the mic there, probably?
Thank you. For me, it's always a question that I have in mind at the back of my mind. So you are from Bank of Namibia, and I wanted to find out the data science, how active is it at Bank of Namibia? Have you started everything from in-house? And I'm asking this question because I think being around different institutions, I've noticed that most of the institutions like FNB or banks, they have an active data science departments because probably they have borrowed some culture from South Africa. And I keep asking Namibia, for example, most of the institutions, when it comes to centralization of data, querying data from these systems, making sure that the data science department is running and effective is one of the challenges. And I keep feeling like the most focus should be probably integrating, especially in our curriculum, integrating the data infrastructure and data engineering, because that is the first step that organization or institution has to ensure in order to make sure that this data is actually accessible and it could be analyzed and data scientists could come up with these models. So what are your intakes in this? Thank you.
Okay, thanks very much. That's a very interesting question, actually. Okay, so in actual fact, we have a data teams. So I'm one of the data team. But for now, we have mainly two types of data set. We have structured data set and unstructured data set. And most of our data, most of them is mostly unstructured. So for now, what we have, since I just joined also recently, for now is to establish, we have an entire roadmap into our data analytics strategy. But for now, the focus is more on bringing all these different data sets into one repository and also creating a data warehouse. And for now, it's more on building about the foundation of data based on data engineering. So currently, we are mostly doing more data engineering compared to actual analysis. Actual analysis is still there; we are doing it, but then the focus is more on bringing this data set into one repository. I'm not sure if that answers your question.
Yeah. Yeah, so I don't know. I felt like probably we need to have roundabout conversations about current data level in our country, because I think we can be a little bit ahead, where we are more on AI and data science. But the question is, are we ready? Are the institution ready to have these models deployed? Or probably we have jumped on important steps, because data engineering as well is one of the most important and critical skills that we need to focus on. So I think probably this is some of the conversations that we should have, because digitalizations, data centralization, and data management, and ensuring that we can access this data for models should be the first foundations. And a lot of institutions really is the main struggle why they are not opening up to have positions in data science and artificial intelligence. And as a university, I'm sure we are aware as well, just to make sure that we align this problem to solve what is the current challenge now in the institution. So thank you for sharing. I just felt like I want to share this because it's something that I have observed and kept it to myself. Thank you.
Okay, thanks very much. And I definitely do agree with you as well. When it comes to data science and AI, it starts all the way from the availability of data, where the data is currently sitting. So, and I can tell, and based on my experience, most of the data is not easy for it. And that's where most of the work is. Most of the work is allocated to data engineering to build that clear foundation in order for us to build this massive AI and ML solution. Okay, colleagues, is there another question?
Unfortunately, I will have to cut you. I know you're now enjoying this part. Let's take this opportunity to thank our presenter for this previous session and job well done. Right, yeah, we forgive you for not being here yesterday. All right. Now I take this opportunity to announce the next session, which is exciting, which is a panel session. And as we had our keynote in the morning, setting the tone for this keynote. I think this is going to be exciting. So allow me to introduce a panel titled Namibia-Specific Applications of Large Language Models. And I'm going to invite the panelists, starting with Mr. Joseph Matukanke, Customer Experience Administrator or Mutual. Can you come and take a seat, sir? Right, while this is coming, we have Prof. Tutaleni Asino is online. Maybe you can confirm if you're hearing us, Prof. He's an associate professor of Oklahoma State University in USA. Prof.
Greetings, I can hear you well.
Oh, perfect. Then I have our next panelist, Prof. Jose Quinam, Professor of Software Engineering at NAST. And our last panelist, Dr. Wanja Juguna, Senior Lecturer, Journalism and Media Technology, also at NAST. And I have the pleasure to announce the moderator for this session, Dr. Lamika Mgongo, the Head of Department for Software Engineering.
Thank you very much, Prof. And yes, so this panel discussion is going to be very, very interesting. And I also want everyone to participate in this. And so before we actually start, because we are not going to allow our panelists to actually define what language models are, we want to get to the meat of what it is. So large language models are actually a subset of artificial intelligence. They use techniques of natural language processing, but how they are trained, they are really trained from large data sets of data. And in the current state of large language models, this data comes from the internet, scraped from the internet, but we know there are a lot of issues with that, that it's not representative. But the whole, the aim of large language models, or the goal, is to really be able to create a model or a machine that will be able to then have a dialogue or conversation, or have with ability to respond to these dialogues and also perform other natural tasks. And to put it simply, and I don't want to use a lot of jargons, think about this. You have a data set consisting of text. And so what the model tries to do is to really create relationships between words. And then using the context to then be able to know what word to predict next. So if I start writing something and say, how are you? Or good, and then the model can predict the next word to be morning. So with that said, these are just a bunch of some of the large language models that are out there. And, you know, you have heard of ChatGPT, you have, there are also some large language models from Hugging Face. Pretty much everyone is doing large language models. Google is bad. There's also another AI startups that has, a lot of AI startups that are creating these things. And although some of them want to really create models that are becoming like gods, all knowing it all, and all these things that are really messing up. So, but although tools such as ChatGPT are really good at mimicking human-like conversation, and they can even fool you with this nice Oxford English and all that. But if you give it any Namibian language, you will actually be surprised on the nonsense that it gives. It gives a lot of garbage. And if you mix two Namibian languages, it's even worse. So this morning I woke up at 4 in the morning. That's the time I wake up. So, and then I wrote, you know, I was just trying to have a conversation. Look at that. I don't know if that typo. I don't know what is that. And then I was like, holy penny, where are you in Oshuambo? And then, you know, look at that long nonsense. And then I was like, like, I'm going home now. I will see you tomorrow. And it responds with such nonsense again. So with that said, and that context said, we are going to go into our discussion. And like always, our discussion follows Chatham House rules, which is very, very simple. One rule, with it, you are free to use any resource that the speakers share, but you shouldn't, if you can post about it, but you should not attribute it to their names. This or to anyone's name here in the room, because this will then allow us to have this open discussion where we can freely talk about want to discuss. Okay, great. So to start, we'll start with the first question, which will then give to our first panelist, Dr. Wanja. And the question is, what are some of the practical use cases of large language models when it comes to journalism and culture, and how we can actually contextualize them and use them in our Namibian context? Doc, you can just start with a simple introduction of yourself and then you answer the question. Thank you.
My name is Wanja. I'm a journalism lecturer here at NUST. Let me start by just giving a simple, it's not an incident, or it's what's happening now with us in the teaching area, especially in journalism. I had one of the courses I had last semester. I taught students to write a story, and these are actually higher classes as graduate students, and I give them a story to write. I think many had not realized AI is in the eternity now, and that becomes tricky. Before it was fine. And as I looked at the stories, I realized two of my best students had an AI of 98% and 96%. And I think I posted it quickly in our group, FCI group, and asked, guys, what do I do? But then again, I went back to them and I asked them, you're good students. What happened? And then the explanation came out, and one said, I was too busy. Time. I decided to use ChatGPT, that one. And they actually used something called I'm forgetting it. Chatbot. Yeah, chatbot. And the other one, I asked the other student the same thing, and it came out. Now, I said, you're going to redo these two stories, and you're going to give me stories that are not helped by chatbot. So welcome to journalism. This is where we are at. How does it help? How does LLM help journalism? So many ways, especially here. There's so many ways of doing it. Interviews, for example. One of the ways it's helping is you can simulate an interview. You're going to interview the minister of this and somebody, and you can actually simulate an interview, and you'll have the expected answers. Fact-checking. It is actually made it much easier to do fact-checking, to create a storyline. You don't use what you have gotten, but you have a rough idea. But with this comes other challenges, ethical challenges, because if you're going to use someone else's information that's not yours, what are you going to do about it? And what's happening now, there's some media houses, not so much locally, but internationally. I think there's one in Bavaria that has a different set of ethics, journalism ethics that they're using, about 10 of them, that are only specific to AI, because that's where we are getting at now. But locally, there is so much you can do. He's just talked about language, how you tried to give it some language. But now, on the other hand, there's also another way you can actually use the same one. You might not use Oshiwambo, you might, because I'm not sure they understand Oshiwambo very well. But also we can manipulate it to give us some answers. But it is very, very helpful in journalism. Remember that there's a lot of media houses that are down. They're actually, a lot of people are losing their jobs. Let me put it mildly. So what do you do when you have a newspaper to produce and you have only about 3-4 people in the newsroom? What are you going to do? They have to make use of this. They have to make use of the tools. But then again, they have to be ethical about how they use it. So there's a lot that we are gaining. Content creation. It can create a lot of content for you very, very fast. If you have a deadline, and news media is about deadlines, and you have a deadline for 1 o'clock, and stuff like that, you can get a lot of information. But on the other hand, you have to be very careful about the ethics. whose information are you using? Stuff like that.
Thank you very much, Dr. Wanda, for that. And my next question will then be, these tools are good, but the fact that they are created using data set that's not representative, they also pose a risk of erasing cultures that are not represented in there. So, for example, the underrepresented groups. So what are your views on the risk that these language models pose in erasing culture, especially African culture?
I don't think we have much of that risk now, because the advantage also of LLM is digitization. And I remember when I came to NAST about 12 years ago, there was actually a project that was going on digitizing information from different cultures. And I think, God willing, we might get into something, again, looking at marginalized groups, for example. It is a project that we might get into if we get funding. And the advantage now is because LLM also includes digitization. Some of the things that, in fact, it makes it easier for us to digitize any information that we get about culture, for example, to ensure it's actually, there's longevity. 100 years from now, I don't know what we shall have. Before you know this, there's another one coming. Before I knew, we had, was it GPT? We started, was it one? Now I think we are at 4. I don't know what we'll have tomorrow. So there's it's continuing. So how do we keep these cultures? There's a lot of information about culture. How do we do it? Digitizing. That's the best way to do it. I'll give a simple example that about 2 years ago, I went back to where I used to work at a media house in Kenya. And I wanted to get some. I have a lot of my own articles, maybe over 1,000 that I've kept, but there's some I couldn't find. And I went back to them and I asked them, can I see what, the newspapers, they told me they had digitized them. But I also realized they had digitized in black and white. I wanted my colorful, stories with all this color. So I looked at those stories and I wasn't sure I wanted to keep that because I was going to use it in a book. But now I've seen others and what they do, they actually have a lot of information in real time, almost in real time. But because they're going to preserve. So I think there's going to be preservation. It's going to help with preservation. And one of the things I was looking at, there's a bit of the issue on languages, you're looking at it, but there's I think that I can't remember the name, but I think it's called Mandla, and you guys can check it out. And one of the things they've been looking at is how to, one of the things that came out is, whereas these things might not understand some of the languages in Africa, but we can feed them. There's no way they're not going to understand because it is us who are going to feed them to understand Olipeni, what Olipeni means, stuff like that. I don't think we have, as long as we make use of this information and we save it, digitize it, we are not going to lose it, but it is us. This is where now there's AI that is, generated, computer, but there's that, we are also going to be part of the generating that information to tell them what Olipeni means, so that we don't lose that Olipeni and we get to know what it means. So there's a part of us that's going to be, there's the, automatically generated, automated, but there is also that we are going to play a role, that's what I believe, in making sure that our cultures and the information is not lost. I don't know what that is.
No, thank you very much. I definitely agree. We have to make sure that we and then actually participate in the development of these models and ensure that, our own languages, like we have had in today's keynotes at the beginning, that we need to make sure that we curate our own data sets so that our languages can be presented as well. And moving on to the next question, I know, Joseph, you work a lot with some of these large language models. So my question is, how are these large language models being utilized? How do they utilize NLP and, for example, the task of text generation, sentiment analysis, and language translation? Maybe you can just give more on that, just step by step, so that everyone understands.
Thank you for the question. Well, in terms of these LLMs being used, so to say, for text generation, it's very crucial, like in the context of Namibia now, where you can, like in the case of where you want to sort of do from organizations, perhaps you want to do news blogs or blog posts or whatsoever. This comes to come up with also new content in a case where, like there's been spoken before, that there might be in terms of the number of employees are not enough, and this can also help you also to use that, for example, text generation. And in terms of translation and sentiment, for sentiment, can get public views, opinions, can be on certain, issues, social or political, or perhaps for organization in the industry or the university, about product reviews, and then on what things they can improve on based on the public reviews. And translation is sort of a big challenge, as mentioned before, that we can't really understand most of the local languages or African languages, so to say. But it's something that we can tackle off. I think it has to start with us being able to generate or able to collect data sets that is between those that are in the industry, researchers and universities come together and bring about this data set that we can train our models, or being able to be in a position that these data can be used in these LLMs. And I think recently, I don't know whether it was yesterday, where now the LLM from Google, which is Bard, is now available in 40+ languages. So it can, I think it can now, one of the things that I've seen is that it can now chat to it in Swahili, for example, and which is a good thing. But then you compare, I think, Swahili, and you compare to, let me say, Chiarello, you don't have enough internet text or data on that. But I think we are in a good space. I think as the youth, everyone in the industry, I think can play a good role, and it can help also us to sort of like I said, in terms of like sentiment, one good thing that I can think of is that we used to you can grab data from Twitter. You can also, depending on the number of, on the hashtags that people, things that are interesting to people, and also based it on location. And you can really get an idea of what the public is on about. And yeah, overall, I think also I can think of another project, which is when you have campaigns and manifestos during presidential, some of the political parties sort of put out these manifestos in PDFs, and you can, if you're lazy or you just want to sort of get an overview of what the whole document is all about, what you can do is that you analyze that document and also you can ask questions since what do you think about the whole document? Why do you see, compared to the current affairs that are happening in Namibia, based on the document, and we can get a lot of insight. So I think that we're in a good position in terms of utilizing this, in terms of also, organization, to know also your brand, how is it being perceived also in the public and things like that. So yeah.
And practically, how can I develop a model? How easy is it to develop something like that? I know you have worked on Airbase, and if I want to develop something similar to Airbase, maybe for Silog, how easy is it?
Well, I would say it's not that easy, but I can't say it's that difficult either. So the question now it's about data. So it's all because now I see it's more of data issue. Once we get to a point where we have enough data, we are able to develop these models. But the current issues that we're facing is that there is not enough data on it, and these large language models they'll need to use massive data set or amount of data for it to be able to get some of the content. But maybe to give you a point is where you can start. It's we have platforms like Kaggle, and you can find some on Hugging Face, and they have pre-trained model which you can now fine tune to your own data set, and then that can also help in terms of computation, and as well as you having to have your own infrastructures and things like that. But otherwise, the first thing we can tackle with it, starting with data, and then from there on, I think we can be in the right direction. So yeah.
Yeah, thank you very much for that. No data. Although today I read an article that more data does not mean data. But yeah, that's something that we can discuss. There we go. Professor Sino, I don't know if you can hear us.
Yes, I can.
Okay, good. It's good to hear your profile. I know it's 5 a.m. in the US, but
Yes.
thank you so much for making our panel discussion. So my question to you, Prof, is that we have been hearing a lot of this doomerism about the impact of AI in education and how these large language models are going to make students lazy, students won't read anymore. But before you touch about that, maybe you can just give us some practical use cases of how we can use some of these large language models to improve education in Namibia. And then later, maybe you can then also talk about the doomerism to a certain extent.
Thank you. I'm happy to be here, and I hope everyone is hearing me okay.
Yes, we can hear you okay.
Fantastic. In education, we are really finding ourselves in familiar territory in one way, because for some of us who study the history of technology in education, this is very similar, going back to even the areas of the printing press. We have always been afraid and panic about whenever a new technology comes around. When the printing press became sort of diffused, early concerns were about people no longer able to remember things. When film came around, some of the arguments was that film was going to replace teachers because it can teach better than a teacher could. So we're finding ourselves in a similar place when it comes to education. But like you said, we can come back to that a little bit later. But in terms of really sort of practical application in education, and some of these practical considerations are just that, they are consideration because we are still not there yet. And I think we are close, especially in the Namibian context, but we're not there yet. Some of the very practical applications could be something just like providing assistance with tutoring and homework. LLMs can act as virtual tutors to help students with their homework, assignments. They can answer questions across various subjects and explanations. So depending on what task and assignment the student is given, or if they're having difficulty, the student can use these platforms to be able to assist in that. One practical example for me that I would love to us to get there in a Namibian context specifically is around the area of language translation. We have very rich, robust languages in our country, but many of us don't really know each other's languages. This is a larger conversation, but I would love for us to be at the point where our students across the countries are required to have more than to learn more indigenous Namibian languages in school. So I would love for us to get to the point where given the multilingual nature of our country, where we can use LLMs to aid in translation services as well. So from an education standpoint, you can also help create learning materials such as, help an instructor start off with lesson planning, create different quizzes, tests, worksheets, and so forth. That's another practical example. In the area of research, for example, it is also good at helping students and researchers retrieve information, especially if you're doing perhaps systematic literature reviews where you have to go through massive amount of research papers. I think these platforms can help do that as well. But there's also really some other challenges and ethical considerations that we need to think about. But I'll stop here just in case we can come back to these later.
That's very good, and maybe I'll just have a little follow-up. So, what do we need to put in place for us to be able? Because creating large language models it's not easy and it's not cheap either. So, what do we need to do? What kind of infrastructure do we need to put in place so that we'll be able to be accessible, especially for people in remote areas? You always remind me of the remote areas. Think about somebody who is in Okambwati. There is not even a road, they don't even have electricity, the school does not have electricity. So how can we make sure that they will be able to, for example, use like language models to learn, let's say, the Mara number from this?
Yeah. For me, I think there's one experiment that happened in Namibia that I think has really fundamentally transformed the presence of Namibian knowledge on the web. And I think for me, that is a few years back, and I think Dr. Lambe, you can remember this, is that NASD had a Wikipedia hackathon. And before that, we had such a limited amount of information about Namibia, context and history, our leaders, politicians, and so forth available online. And after that, if you look at it today, there is so much information out there. And I think I attribute that to that experience of having a hackathon where you're generating the data that goes out there. As we know, and you said this in your introduction, most of these LLMs are trained on data. And we know that the importance of data is really what is driving a lot of these things today. So I think the other question we have to ask ourselves is, how do we generate enough data that allow our context and our histories and our information to be put in there? Because at this point, even if I come up with a really great program, let's say a Namibian ChatGPT version that is free, accessible, can work in all remote areas, the fact still remains that the data that is in that system is not necessarily representative. So we will just be ending up caught in this same system where we are giving access to technology, but the content that is embedded within that system is probably going to be doing a lot more harm to the people who are accessing it.
Thank you very much, Prof. We'll definitely get back to that. And I know Prof. Inem is not happy with the question that I've given him, but it's my rules. So unfortunately, my rules to be green. So, Prof. My question to you is that we, as part of the AI, there's also been a lot of doomerism, but we're not going to do doomerism today. We want to, what are some of the practical limitations of that are associated with these large language models, especially when we come to real life use cases, and how can we address some of these challenges or limitations? Thank you very much. Okay. But first of all, the previous panelists touched on the data issue, and obviously it is a challenge. And the example that you used at the beginning, I mean, says it all. I think you did it on purpose, not make sure that the model you were using was not trained in the language and still shooting questions at the model. So clearly, if we want things, if we want to benefit from large language models, we have to make sure that the data, the adequate data is actually fed into the model, or at least we get existing models and we train them in the proper context. And then there's the issue of the interpretability. And then your example shows it again, that assuming that the model was trained, right? The questions you were asking, so some people are mesmerized by ChatGPT. They'll tell you, but it gives you answers. What's the accuracy? What's the quality of the answer that you get? Right? So interpretability, first of all, understanding how we got to the solution. Because in certain areas, you cannot go to a patient and say, my model or the robot said we should do this, right? People need to understand how you reach that conclusion. And then there's the quality of what the model is telling us. The third challenge I can think of is the ethical issues, and it cuts across. If we're dealing with data challenges, if we're dealing with interpretability issues, obviously fall into ethical territory. Make sure that the ethical rules are properly spelled out and enforced. And the final challenge I'd like to discuss here is the issue of computational power, right? For those who have dabbled into large language models, they know that behind this is just a transformer. The transformer is really power hungry. So you cannot build those models if you don't provide enough computational power. Training those models. That's what I can say. Yes, thank you very much for that. And I also love the fact that you touched on the power hungry nature of these models. Is there perhaps a way that we can maybe rethink how we, from a technical point of view, how we develop some of these models? Do we perhaps have to start rethinking of not just increasing, the parameters of the model, but rather thinking of how do we create simpler models that will actually use less electricity, because we know electricity is also a challenge, especially in the global south. There are this load shedding in South Africa. Even here in Namibia, we are also not energy secure. So, and as long as these models continue to be power hungry and computational hungry, we are going to, there will always be a divide. Those that have more power will be able to build those stronger models, and those that do not have power will not. Do we perhaps have to rethink in terms of architecture what we need to do to kind of like make sure that it's the training of these such models is accessible to everyone? I think today is your day, because throwing all the things that projected back at me. It's just a follow-up on the conversation we were having yesterday. I think you're right. We cannot just accept the status quo. We have to think much more carefully how we go about training these models. And sometimes you ask yourself, is it necessary to have a large, omnipotent model that can answer all questions? Or is it better to have, downgrade the scope of the model so that it does less, but it does it accurately? So that's a conversation to have. But if you look at it from an arithmetic point of view, does that mean that if you train more smaller models compared to one single big model, does that mean that you're consuming less computational power, less energy? I'm not sure. So I think we have to sit down, run some tests, examine this carefully before we, make a decision or take a position that, obviously we agree that these large language models are not always necessary. But where is the limit, right? And that can only come with all scientists projects here. So at one point, we'll have to go through experiments and measure things so we can accurately tell people this has worked, this doesn't work, and this is where we believe we should stop. Thank you very much, Prof. At least we agree to that extent. There we agree 100%, I think. And I think we have been having discussion amongst ourselves for over 30 minutes now. So we are actually opening up the room, the floor to questions from the room. Do you have any questions from the room? No questions. Nothing about whether ChatGPT is going to replace your jobs or is okay. If there are no questions, okay, there. Maybe you can just come closer. Yeah, just come.
Good day. I would like to ask, so even though ChatGPT has existed for a couple of years now, how does critical thinking skills in humans still remain? Because it won't make sense just relying completely on ChatGPT to have everything, generate everything for you. So how does that still remain in play? And when it comes also, another question, when it comes to training data models, is it as simple as getting a bunch of text from a lot of individuals going into remote areas and gathering as much, or just getting a dictionary online that has all these different words and definitions that you just incorporate into a data model and then train it so that it knows what it's supposed to do grammar-wise? How is that going to be?
Yeah, thank you very much for that question. Maybe we can take the last one.
My question is not related to today's panel discussion, but it is related to AI. So my question is, how do we integrate and use artificial intelligence and machine learning in the crisis that we are now facing of climate change? How do we reduce the emissions of carbon in regards to AI machine learning?
Thank you very much. So we'll, I don't know who wants to start first. Yeah, and then you can just pass on the mic. Maybe I can start with the last question. AI itself is already increasing the carbon footprint. I don't know how we're going to use it. It's like the hydrogen problem. People say it's good. I'm not a physicist. I know nothing about this, but people say it's good energy. But they call it the champagne of energy, because before you get there, you have to use a lot of energy to produce that. So we always have these challenges of, people have been selling this idea of electric cars, right? But if you look at the consumption of energy, how much energy it takes to actually charge those batteries, then you start asking yourself, okay, is that equation really correct? So, of course, there are many solutions at this point, doing a bunch of modeling, doing a bunch of exploration, and they're trying to participate. But let's not forget the fact that all these efforts are actually consuming, they're using computational power, and therefore they're increasing the carbon. That's what I have to say about that last question. On the previous question, I think I'll just take the first segment question in the how do we keep the critical thinking? And as you were asking the question, I had an example flow into my mind. I don't know if it's completely accurate, but imagine a junior sysadmin that gets a job. Now they have to install and set up a system. So there's a documentation, right? They can follow the documentation. Now, instead of following the documentation, you query, you ask ChatGPT the steps of setting up the machine. Now, the tools that you want to put on the machine might be having different versions, and probably there's no documentation yet for that version. And there comes a point where you have bits and pieces of documentation. They're not properly aligned because the versions are not the same. And eventually, you, the human being in the middle, concatenating all these pieces of information, if you don't apply your mind, you'll be sitting with, a wealth of information and not knowing what to do with it. That machine will never start, right? So that's what I have to say about it. What I'm trying to say is that those tools are at our disposal for us to use them wisely and smartly. But if we just give them the power to control us, it will totally.
To answer the one in terms of collecting data, yes, it will be good to go to those communities and get rich text and just to be inclusive rather than collecting data that is already available on the internet or within a certain community, and then that will rather create biases in your model. So yeah, but again, it's the question of data, but also sort of like research funding, so to say, for you to go to access those remote areas and things like that. So it will also cost money to be able to do that. Also, to be fair, it would be nice to also compensate these people, just not to sort of get their knowledge or help you in building these models and then you leave them out in the dark. But yeah, I think it start with research grants, which can also help accessing to those and accessing those remote areas, and also being able to compensate, to fairly compensate people that are providing this knowledge or information. So yeah.
Professor, do you want to comment?
Yes, I wanted to come in on the question about critical thinking. And it's a good question, and it's a realistic concern, especially when it comes to the area of education. And it's a long-standing question. And I always say that we have to keep some of these things within proper context, right? As a kid in the north, going to school in Okahau, I remember classmates who would cheat on exams, on tests. I'm not gonna say whether I was one of those people cheating also, because I don't want to incriminate myself. But people will, if you remember those old pens, the big pens with a clear cover where people will write really small text and put it in their pen so that they can take it out in the exam and be able to cheat on that. So I think sometimes the issues of critical thinking can be a proxy for us thinking about, well, are students not going to learn anymore because they're just going to be cheating by going through the systems? And I think on the one hand, it is a valid concern, but I think as educators, we do have abilities to address some of these things. So for example, in my classes, one of the assignments that I like to give is I say, okay, here's an assignment that you have to do. And I want you to use ChatGPT to answer this question. So students use that and they get a prompt on an essay that they were asked to write. And then as part 2 of that assignment, I give them and say, okay, now take the prompt the response you got from ChatGPT and rewrite it in your own words. So now that helps and forces the students to re-examine and critically look at the output of ChatGPT and put it in their own understanding. So we have concerns about whether or not students' ability to write academically is going to be affected, and that's a really valid concern because it's going to generate text for them and they might not really understand it. So we're going to have to find creative ways of ensuring that our students understand the material and can think deeply and critically. And then we also, as educators, have to ask ourselves, if we are giving prompts or questions, exam questions and so forth, that can be easily answered by simply Googling a response, then we have to also take the responsibility of now adjusting how we're asking things and asking and teaching our students how to be able to ask questions in a more effective way.
Wow, thank you very much for that, Prof. Don't know, I see Dr. Wanja here smiling. I don't know if you want to add something to that.
Thanks a lot, Chair. I think I concur with Professor Sino because I still remember when I posted that time when I was panicky, and I posted it on our FCI group, and I remember the comments that I got. And I go back to that, and it was almost similar to what Professor Sino has said. And it was, we need to start rethinking how we are going to use ChatGPT to our advantage and to the students' advantage. Because many of them, of course, are going to, the first thing they are going to do. I tested today, like the questions that you sent. I told my son, can you create, this for me? Can you find out the answers for this? I just wanted to know whether he's very conversant. And I'm busy doing something else. In like 3 minutes, he already had the answers, and he says, Mom, here they are, all there. All the answers I've been working on the last 3-4 days. In 3 minutes, the guy had all my answers there. And they were good answers. I could have basically used them right here. And I thought, so I asked him, are you going to use this in your assignments or something? He said, I'm not going to use ChatGPT to answer my questions, but I am going to use it. The ideas it's going to give me, I'm going to use them to think of how I'm going to. And I think that's one way. The other way is it's going to be very tricky, but it's doable. How do we actually phrase the question so that it starts, I actually like his model, where he actually starts with ChatGPT, answer it in that, then think the other way, because most of what the students are doing is starting with that, and that's it. If AI was not in Turnitin, we would be in trouble. Thank God the TLU put it there very quickly, so it's helping. But now I think that there is a way we are going to use this positively, because it's here, there's nothing we can do about it. It's here, but we are going to use it together with the students to see how it can work for us, especially in terms of critical thinking. Otherwise, we can't allow our students to deteriorate as we are watching, and we need to. But even for us lecturers, it's answering some of the questions very, very easily.
I use ChatGPT.
Yeah,
it has become part of my what you call process during the day.
Yeah,
I wake up and I don't have anyone to talk to in Germany.
Yes.
I talk to ChatGPT and
so I think there's a lot of positivity. It's how we are going to use it to work for us, especially in terms of education, of the quality of education, because we also don't want to produce students who go to the bank and they can't they can't do the math or whatever they're supposed to do, and they say that they graduated from last year. So we don't want to do that. We want to help them do that, but positively. I think that's
okay.
I think in that process, let's not forget, because we're all thinking, okay, we need to do something, we need to do this, but it should be an institutional effort. That, for example, as a university, we have assessment policies. So as we're looking at how we should integrate ChatGPT in our whole teaching system, we need to think of policies, the assessment policy needs to change. How do we integrate these things? How do we allow the student to use them to a certain extent, and make sure that when we're assessing them, we don't want them to just.
No, thank you very much. And it's not only ChatGPT. There are a lot of large language models. Some of them are even better than ChatGPT, but ChatGPT is the one that came first and laid in our hands. So that's why maybe we talk about it. And I know I do not want to end this conversation. We'll continue, but I think because of time, we have to catch up with time. So we'll ask the last question to our panelists. And we have had, since the rise of ChatGPT and other generative AI such as DALL-E 2, I don't know who has used DALL-E 2, the ones that you put in something and it draws for you. Yes. And we have heard all this doomerism, and some people are like, oh, AI hype, we are going to have these models that are going to do everything. They are going to take away people's jobs. And some people are even going to end up saying that there is what you call existential risks. We have heard about the existential risks. Yes, even some of the big people were like existential risks and all these things. So my last question to our panelists is, how do we separate all this doomerism from the hype? And how can we ensure that we really create good AI systems that will help our society? I don't know if we start with you, Prof. Asino from online.
Thank you. I think, for me, this and you appropriately title it doomerism and hype. I'm always reverted back to Thomas Edison's quote of that he said in 1922 that film was going to replace teachers, because at that time, 1922, old school film that you roll on a wheel was a phenomenal new technology. And people were saying, oh, that's what's going to replace all teachers in the future. So anytime a new innovation comes about, we are always split in these two categories. One is enthusiastic imagination about what the future can be. And then there is the other part of, oh, wow, this is going to end the world as we know it, and so on. Let's not forget that at some point, we thought that Y2K was going to be the end of life, and we will be flying cars by the year 2000. So this is not new. But at the same time, it is also an important conversation not to ignore, because AI is in a way different from other technologies that came before it, because it has a lot of different potential. So we have to really be critically examining some of these things, and we can't just dismiss them as overreaction, because it is a practical concern that a student is not going to have writing skills if they're only able to submit a printout from ChatGPT. So those are really valid concern. But I think that one of the best way that, especially for the Namibian context, that we can do is, one, we can't be behind this conversation. We have to generate our own data that is going to be able to help train some of these machines. We have to ensure that we are also questioning and asking from our own context, and not simply adopting the tools that are coming in from other spaces. So I think, for me and Dr. Lamek, you and I are on the same page on this in different conversation. I think we are overreacting too much in some of these spaces, but on the other hand, perhaps it's good that we are overreacting so we can be a bit more cognizant and questioning, and not just accepting this as the greatest thing since Kapana was invented. But I think we have a lot of opportunities here to really start asking difficult questions and be much more involved in the conversation.
I'm old enough to remember that, the hype has always been. The way AI was sold to me in the 1990s, that, in a few years, we'll have machine talking to human being and bodies. That's how it was sold. And so how long it took for us to get to very trite conversation of what we're having now is nothing near meaningful conversation when you go deep into getting business done in a certain area. So I think, and you can, the keynote yesterday, the time frame that we followed. Now the neural network, they've been around for a while, but they only picked up 10, 15 years ago. So I think we have to be focused and seize the opportunity, what is ahead of us, but also be careful about the challenges, tackle them one by one, and have a critical examination of what we're facing, the tools that we bring the implements that we use to actually address the problems.
I'll speak from a journalistic perspective. A lot of newsrooms are downsizing and bringing the current AI and everything, and it may look bleak. It is going to be positive. Positive. 2 years ago, before COVID came, there's a lot that we didn't think we could do online. Today, almost everybody understands content creation because we were at home doing a lot of nothing and we started getting creative. And people are no longer, there are very few people, people who go into doing something are busy, they're making money. We didn't know we could have meetings, boss meetings, for example, remember, online. Boss meetings is one of those meetings. If you're not a lecturer, you will not understand, but there are those 2-3 hour meetings that we have as lecturers to strategize on making our institution better, but it can be tiring. Now, having them online is much easier. So what am I saying? In terms of journalism, for example, these new areas are actually improving on our storytelling. Digital storytelling is the in thing now. I don't even need to go to a pool to do that story. I can find a way of doing my story by giving instruction. It's going to make things easy. Some people might not have to work inside the newsroom, but they will still be able to produce information for the newsroom because things are getting easier. Again, for me as a journalist, I'll come back down to ethics, the basic ethics that we have already learned on interviewing, for example. There's something we call armchair journalism, where I just sit here and I don't do any research. I just, make a call or use a press release. And, there's a lot we can do with what we have now by interrogating. Even a press release, when you get it, actually, you can use the same technology to actually find out what exactly is inside this press release that I'm looking at. You can actually get more info. So there's a positivity in terms of, reducing the newsroom. I think they may become smaller physically, but then they'll be able to use many more people to do much more than they were doing. So I am looking at positivity, and we should all be making use of what technology we have now to become the money. Side hustles, we can do that. That's the way I look at journalism. There is a future for it. It's not going anywhere anytime soon. Maybe the newspaper, the print papers might reduce, but not the journalism. Yeah, it's actually going to get better. That's what I think.
Okay, my take on is that I think the hype is good because, it also helps that us, people, we're testing out these systems and also allow us to sort of get their limitations, what they can do and what they cannot do. And perhaps now that we know they can do certain things, they can also help us in getting those tasks faster rather than spending hours and days. But also getting to know that they're not capable of certain things also help us be able to sort of get into that domain and also not just rely on AI. But overall, also the thing should be solved by where you don't introduce biases in the systems, whether whatever you have to do with the system. But I think the hype is good, and it's not going to, I don't think it's, the existential risks. I think people are much more concerned on biases where you have a certain group which is much more represented in these systems rather than the overall population. But once we're able to tackle those, I think we just don't need to be in denial of that. Yes, it solves all the problem, but not to say it solves all the problem, only certain problems that it does, and it does very bad on access to problem. But I think it's going to be there for a while, not forever, but yeah. Thank you.
Okay, with that said, I think we can just end our conversation by saying that, of course, artificial intelligence is here to stay, and unfortunately, large language models are going to become more and more increasingly used in different fields. And one of my favorite fields, healthcare, there are a lot of opportunities if we develop these systems in a responsible way, that we can really create very, very good large language models that can aid doctors, not replace doctors, aid doctors, because we still need the accountability aspect. And I know, Josephine, you want to ask a question, but I think because of the time, we can actually take it to the break. And with that said, let's just give another round of applause to our panelists. One homework for everyone. Can you please scan that QR code and help us understand or give an African perspective on what AI trust should be like? Thank you. Okay, so it's lunchtime now, so we can come back here again at 2 o'clock sharp. 2 o'clock sharp. So 40 minutes for lunch.
Oh. Hi, madam. How are you? That's why I going to get something. Everybody go outside to do this. How are you? Yeah. What's your first event? What we stop the because of this one day, I hope we're not actually I think I should leave the working class.
Yeah, because I have a paper that's waiting for me. I just got the reviewers' comments last week, but I have until the 9th of July to work.